which will basically be a session from where you will start. This will be the by default interface which you will get when you install the Python and open the Python. Okay, so this is the main interface. This is the main interface which is called an Anaconda Navigator, which you will have once you install the Python, and you just need to launch this Jupyter Notebook. So we are working on Jupyter Notebook, and this is the like icon you need to click. So once you click launch, okay, so the launch will take you through to yeah. So this will be the interface, and how do you open Python from here is you just need to quickly click on new. Okay, this new will take you through to Python 3. Okay, so some of you might get an option of Python 2. So what that indicates is you have installed Python 2.7 version. Okay, we'll be going through, that is not a problem if you have Python 2. Okay, some of the functionality will be different in as compared to Python 3, but yeah, in our session we'll be completely focusing on Python 3. This will be our like working interface. Guys, you need to give me 2 minutes. I am getting a call. I'll spend some more time on the interface because I got a couple of messages on WhatsApp that they were actually facing some issues in opening the session, right? So the the major problem that we face when we install Anaconda, I'll just make sure that you don't fall into that problem. Otherwise, it really becomes very difficult to bring the system up with Python. Okay, so download Anaconda like for the version of laptop that you are using. If you're using 64-bit, so install 64-bit system. If you're using 32-bit, install 32-bit system. Okay, I have already shared the link to all of you, but again I'll share it. Okay, install Anacondas for Windows. You'll be navigated to Anaconda website. It's very straightforward. Use this link, download the version that you want. So if I want to download Windows system, okay, click on Windows, download whichever bit is suitable for your laptop. If you have 32-bit laptop, install 32-bit. If you have 64-bit laptop, install 64-bit. Okay, so the link is in the chat. I'm placing the link in the chat. You please use this link and start downloading it. Keep it keep the download on the side by side, so that at the end of the session we'll work parallelly to install the software. Okay, so this is 462 MB file. If you are using 64-bit, it will take some time, so keep it on download. First thing. Second thing, once we install the interface that we saw is this interface. This interface it will be, I guess, if you are new to Anaconda Navigator, you need to spare 5-10 minutes to understand what this interface is. There are a lot many things for us as a programmer, as an analyst, to understand what this interface gives to us, right? If you are familiar with any other programming language like R Studio, okay, so you have R Studio here, so you can directly open R Studio from here. Okay, that is the flexibility. You do not need to have a separate R or R Studio. Okay, if you like to code into Python, but you are very familiar with R ecosystem, R interface, so you have something called Spider. Okay, which will give you exactly the same interface like R. Okay, you'll have the same interface like R, like this, but you can write programming in Python here. Okay, you can type Python programming here. If you go to this file, if you see on the plus side, just go there, and once you install that package, you'll get a Python package here, Python name. Open that and start coding in R in Python. Okay, but to make things look like more of an industry and what works in industry, what people prefer in industry, we'll be using Jupyter, because Jupyter is most widely used system, Python system in current time. Okay, so you just need to click on launch. Once you click on launch, so launch will navigate you to the default browser of your system. So if your default browser is Chrome, it will open in Chrome. If your default browser is Internet Explorer, uh, it will open in Internet Explorer. Okay, no issues in that. So what you'll get to see once you open, if you launch the Jupyter notebook, is something like this. Okay, so this will be the exact interface which you'll see. Now let's understand what this interface is. Okay, so guys, majorly in our local system, we this files maps to your local file system. Okay, so if you see you have documents, it will be navigated here. You will see you'll have desktop documents, downloads, everything that you have it in your local system, right? This is your local system. Now navigate to any folder. Okay, for the part of this course, I'll suggest create any folder. Let's say I've created online session and business analytics using Python. Okay, create any folder in your local system. Go back to your browser, navigate from here, navigate to that folder. Let's say I want to navigate to my online Python session. I'll go to documents, then I'll go to online session. I'll go to online session, then I'll go to business analytics using Python. Okay, and then I have reached to that folder which I have created. So navigate to that folder. I've already reached in this folder, and from this folder you just need to click on new Python 3. Okay, so understand this step. You need to go on this new folder. Okay, click on Python 3. So it will open a new window. This will be your new window. Okay, now in new window, what I'll do is, so at the top you see Untitled. Okay, so this is the name of your notebook that you have created. So this entire thing is called notebook. Okay, this entire thing we term it as a notebook. Okay, because it looks like a notebook. You write something here. So rename it. So let's say I'll rename it as class 1. Class 1. Okay, I'll rename it. So the moment I rename it, so if you go back to that particular folder, so you see class 1 is being created. Okay, seconds ago, and it's running. That means it's a live session. It's running class 1. Okay, now let's come back here. So this is the this is a portal. This is the interface where we code, right? So this is a portal where we code. So what you need to do is you need to understand the cell. This in the where you see the cursor is blinking. The place where the cursor is blinking, that is called active cell. Okay, and you write here print hello everyone. Okay, and you click on run. So this runs. That means this cell got executed. As this cell got executed, you got the output. So you write code here, and in the same place below you get the output. And this is called interactive language. You interact with the language. Okay, whatever logic you build here, that will give you output here itself. If you write if you get any error, let's say I purposefully make some error and I'll run it, so you'll get the error here, invalid syntax. Okay, what it says, you are missing code with the arrow. So you need to just go back, give an arrow, run again, you get the output here. Okay, this is the purpose of active cell. Okay, this is active cell. So whichever cell is blinking, whichever cell you see the cursor is blinking, that is called active cell. Okay, and that active cell basically is green in color. You see it is in green in color. Okay, the moment you press escape, it becomes blue. That means the cell is no more active. Okay, again you press enter, it becomes green. Again you press escape, it becomes blue. So you need to understand which cell is active, which cell is not active. It is for simplicity's sake. Okay, once it is not active, you can this will not run. You keep on clicking on this, it will not run. Okay, it will navigate to the next cell. So for running it, you need to click on that cell. And you see here IN. in and bracket empty, that is called input. Okay, this is input, and then you have a blank. That means if you have a blank, that means this cell have not run yet, it is not yet run. So if you write anything, and run it again, so you see the number will come 5, that means it has run. Okay, now you many a time, like once you get very acquainted and use interactive with the language, you'll have to use a lot of shortcuts, and that shortcuts is basically become better, that shortcuts becomes your day-to-day activity. So one major thing becomes that is adding cells, removing cells. Okay, if you want to write some more line of code, you need to add cells below, right? Here you need to add cells, and if you want to delete some cell that you don't want this cell, you need to delete it. That this something like this becomes very common in our day-to-day coding life. So for that you have interface as well. You can definitely add something. If you want to add some cell, you can click on plus, it will add cells. If you want to remove something, you can cut cell. Okay, this you can do from the interface, but a lot many time we don't use cursors, right? uh, we need some handy shortcuts. So for any shortcuts, you need to uh, press escape and press B. B means it is adding cells below. Okay, and if you want to delete anything, double D, it will delete the cells. Okay, if you want to add anything above, I mean like this is, if this is the active cell. Okay, if you need to add anything, any cell above the current cell, this becomes your current cell. How do you do that? You just press escape and A, it adds cells above. If you want to add any cells below, you need to press escape and press enter B, it will add cell below. So these are few shortcuts, add above, add below, delete, which we'll use very frequently in our day-to-day programming. Okay, so if you want to learn more about shortcuts, go to help. Okay, you have a uh, option of keyboard shortcuts. Click on keyboard shortcuts. You'll get lot many shortcuts which are available in Python. Okay, based on window, if you are using window, if you are using Mac, whichever system you are using, so you will get a shortcuts key from here. Okay, fine. So so far I guess we are good. So we once we install Python, we can open the Python, we can open the cell, open a notebook, understand the notebook, right? So are we all good on this? Fine. Now few more properties of this Python notebook that we have seen, this class one. Okay, this has an extension of IPython notebook, IPYNB, right? This IPYNB is basically a like special extension that is only valid for Python notebook. So this is Python notebook, and this will only open in this interface using Anaconda. Okay, if you try to open it from outside any text editor, it will give you HTMLs. Okay, which will be very difficult to read. Fine. So okay, so now let's move ahead. If you have any questions, please go ahead with the questions, or else like we can move ahead with the concepts. Okay, so I'll share this notebook with you. Okay, so like let's try and understand. So Python as a language for analytics is more of a like package driven language. Okay, like you have smartphones, you install packages in that, you install apps in that. Without apps, the smartphone is just, it's just a basic phone, calling SMS, that's it. Receiving call, going call. If you want to have extended features, you need to install relative apps, right? Similarly, Python also is a package driven language. Okay, whatever functionality you want to use, if you want to visualize, if you want to draw graphs, if you want to do some data wrangling, if you want to do some machine learning, so for all this specific task you have a packages. Okay, and how do you install package? We install packages using import. Okay, so there are several ways. So the reason we are installing using Anaconda is it comes with almost all the packages that we'll see. It comes with pre-installed packages. Okay, you don't need to install it individually because it will take time, and that is the reason the file size of the Anaconda is so large, 462 MB. It has all the packages, almost all the packages. Okay, now to bring the package in your session, okay, you'll have to write import command, import packages, package name. Okay, so how do we do that? basically if you see keywords, all the keywords will be in green or blue. So if you see something like, if you see import, it is in green. If you see something like this, which is also in green. Okay, so anything that is in green, that is a syntax, that is a keyword, reserved keywords. Okay, and reserved keywords you cannot use as a variable name. Okay, we'll come to this in detail. But how do you import package? We write import package name. Let's say pandas is what we want to import. Pandas as PD. So PD as PD is not important. If you want, you can skip it. Okay, no worries. So but for the sake of simplicity, if you just import it, import package, and the shortcut to run the code is control enter. If you write control enter, so you see star, after star you see number 1. That means the first cell got executed. Okay, so what happens if you don't give if you use this? So this is a package name. To use the functionality of a package, you have to type always the full name of the package, then dot, to use the functionality. And then if you press tab, you will get all the function, let's say like this, read CSV, write CSV, whatever options we'll get. Okay, so the code in a long run, the code becomes very lengthy if you don't give a shorter name to it. So what we do is, generally whenever we import any package, we alias it with shorter name. So like we alias pandas with PD. Okay, and then run it. So what happens now? Panda is named as PD in our session. Okay, then if you write PD dot, so we get same option. So our code becomes generally in general little shorter than if you don't use alias. Okay, so let's import some of the important packages. So we are importing, let me just delete this, importing pandas and numpy. So this got imported. How do you check that it got imported? If if there will be any error, so you'll get it here that this package, this module is not available. Okay, and if it is available, it will straight away run and you'll get a number here. Okay, if you want to have a further check on confirmation, so you can press np dot. Okay, you'll see all the methods are here, all the related methods are here. Okay, that means it is installed. So if you do pd dot, you get all the methods here. So these two things is just to confirm. Now we'll import the data. We'll import the data in some time. Before that, I want to go ahead with further concepts. Okay, so primarily in Python, once we start, there are a couple of things that will be very handy for you to clear out what the coding is. How do you code? How do you write codes? Okay, so first we'll see the helper functions. So in Python, generally if you type any keyword and if you're not aware of it, so just press question mark. Okay, and run it. Eh, like I mean enter it, control enter, or run it from here, whatever. So the moment you press question mark, that means you're asking Python what this is basically. Okay, you don't know about it. So you'll get a pop-up in Windows wherein you get a complete detail of that particular syntax, what that syntax is. Okay, how do you use that syntax, what are the different parameters it accepts. Okay, see here, print, and it accepts value. If you want to separate it by something, separator. Okay, and then flush is equal to true or not. So after printing it out, do you want it to remove it or not? So this is there and you can use it a lot. After that, more advanced function, you have help keyword. If you run this, okay, you'll get a complete document here. You input what help you want. Let's say I want help in, again, print. Okay, enter it. So it will give you more interactive answers. Okay, what help you want, and it will give you the detail. So if you want, let's say I'll run it again, function. Okay, so they'll say the function, like function, there's no keyword called function. Okay, so let's say if they have any information on pandas, they have a lot of information on pandas. So here they'll give you the entire document on pandas. So just need to type, you'll get a complete document. You don't need to even go to Google and type in and learn it from there. So the complete documentation is available in the notebook itself. Okay, you just need to type it. Okay, and for this you don't need to be online. You can even be offline. With you disconnect your internet and read this. This entire thing is saved in your local system. Okay, any question guys so far? Okay, so you'll see this this thing is star, always star. Okay, that means it is complete. Again, it is running continuously. It is in running mode, and if you go just skip it and go to some other cell and try and run it, it will hang. Okay, so you need to stop it. You need to just halt this execution. You just need to go to this button, interrupt kernel. You click on this, this will get stopped. Okay, you need to know this this when you have star, when you have running. So this will help you to understand when you need to stop the session and when you need to start the session. Fine. So you should be okay with the helper function now. By now, let's go to let's go and understand little something about data types. Okay, so what these data types are, what are the different types of data types in Python? Okay, so before we go ahead, let's understand like the coding methodology. Like how do you basically use coding in Python? So we generally, when we start learning any programming language, so we don't care about this. But in long run, when your program becomes very big, it is very difficult to maintain and understand when you revisit that program, let's say 2 months or 2 weeks later down. So commenting helps, and that's why I teach like basically I deliver this section of commenting in the initial time only, so that it becomes very easier for you to follow it. So in Python we have hashtag to comment a single line of code. So let's say hi. So this line, whatever you put in hash after hash symbol, okay, this line will not execute. So if even if you write some code here, let's say I write 2 plus 2. Okay, so what does this mean is this means that this line of code will this will get executed, but this line will not get executed. You see here, if you run this intersection, so you get 4 as answer, but this remains as it is. Okay, so this is comment, and if you want to have a multiple line of comment, so there's you need to give triple colon like basically this quote actually. Okay, and write your thing here, it will appear in red, so this will also not get, and you run this, so you see this entire this becomes, the entire cell becomes unexecuted. Okay, so you need to if you want to run the cell, you need to give it in a hash like this. If you want to run it in like entire comment the entire thing, you just need to put it in a quote. Okay, so now Python as a language is as I said, it's an interactive and fourth generation language. Okay, so it has some ways in which it runs, and one way which what one process which it follows is basically indentation. Okay, so you need to be very sure but very particular about the indentation. Yeah, Myanmar, so that line will this particular cell will not execute. So the question from Minmo is that this when you run this, this says that this line will not get executed. It just shows this, but it shows the comment. It will not run the cell. It will show the comment. It is not running the cell. So you see, you are not getting. So let me uh, just put this in here. So this I guess your dot is this, right? So whichever this is not running, this line is also not executing. The reason is it was just printing the last line. Okay, and the last line was the comment, that's why. But this is not getting executed, and if you write something in text, this will give you an error. So this will give error. So you see here, you're getting an error because it's not commented out. If you don't want this to run, so you need to put this in a triple quote like this. Then you get a output. So the last line will get executed. If you want to write some comment below below the code, so here you can write it like this. Like this. Okay, this is a comment. This is not giving you an error. The single if you just put hash, okay, it will comment a single line. If you want to have multiple like if you want to comment to be in the output, okay, so you need to put it. And if it is a multiple line, you need to put it in a triple quote, and it will run like this, something like this. Any questions, guys? Okay, fine. So let's move ahead. And what we were talking about was basically commenting is okay, I guess. Any doubts on commenting? Any confusion? Like what is happening with triple quotes and hash? So to make it simple in a line, in one liner, is you just need to give hash when you think you have a single line of comments and you do not want that to get executed. Okay, then you write your code. This is my code which is getting executed. And if you want something which is in a multiple line, you need to put it in a triple quote. Okay, and automatically it will appear in red in color. Okay, now fine. So one thing uh, that we should discuss now is about the session. Okay, so Python as a language, this Anaconda that we are seeing is a session based language. So what do we mean by saying session is, so whatever you are writing, executing, declaring, importing, exporting, whatever you are doing here, whatever activities you are doing here, that is very much well restricted to this session of introduction to Python programming. The tab which you are seeing, the tab which is there, which I'm highlighting. Anything in any other session, if you open, let's say I navigate to class 1 session here, and I try to do some activity and I try to use PD. Okay, so that PD does not exist here. That PD does not exist here. It does not even know that Python is imported here. Okay, you if you want to use pandas, you'll have to import it again. Okay, so generally what happens, people when they start, they open multiple sessions and try to declare some variable, declare some function in one session, and they try to use it here, and it will tell you it is not declared, out of module, package is not available, something like that, and you get confused. Okay, so just to avoid that confusion, whatever activity you are doing, declaration, importing, exporting, whatever, it should be restricted to this particular session. If you want to use this session, do the similar activity here as well. Okay, so that is the way of using that is the way of that we use session. If you are familiar with Python, R, so you can relate it, because R is also a session based language. Okay, now let's move ahead, and we were talking about the indentation, right? We were talking about the indentation. So what I said is Python is a indentation based language. It means, like, when you write code, you need to maintain this indentation. So what does that mean? So let's say, for example, uh, for example, let's say, don't get into the codes, but just to say, for I in range. Okay, the moment I type enter, so you see here, you get a space of one tab. Okay, so this is there. Here you need to write your code, print hello, right? And you run it, so you get hello printed 8 times. Okay, Anaconda notebook takes care of the indentation automatically. Okay, and that is the reason it is so famous. Like, it has this intelligence of taking it. The moment you disturb the indentation, so let's say you just give one space, you give a backspace. Okay, so it will give you an error. If you run it without indentation, expected an indented block. Okay, that means you need to maintain a indentations, and this is not only with the loop, with almost all the, let's say if you're declaring functions, okay, if you are creating module, if you are writing if condition, okay, so you'll have to maintain the indentation. So make sure that it is following. So what is the easiest way? Easiest way is go according to what Python is doing. Do not disturb the spacing, otherwise you'll have to manually sit and press space, and that really becomes difficult. Okay, so it's an indentation based language. Guys, are we clear on this? Any doubts? Okay, so let's move ahead. So here is some basic theories that I have already written. You can have a look into it. That like Java, like C++, like C, Python also use indentation in the programming. Okay, now let's understand something which is called range, which we'll be using very frequently in here down. So whatever you see here in green, that's a keyword. We have already discussed about it. And this, when you have something in green, that is a keyword. And if you want to understand what this is, just press question mark and run it. Okay, read the document to understand what this range does. So range basically is a function, user-defined, system-defined function in Python, which will give you the flexibility to vary your numbers from one to, like, from starting point to ending point. So let's say if I need to vary my number from range 10 till 20. Okay, so if you just print it, okay, so it is sorry, you need to loop it first. So it will print from 0. It will start from 0. Okay, since I'm not given 0, so it automatically assumes that it starts from 0. Okay, so you see here you have start object, the parameters which range accepts is start object. Okay, stop. Okay, so let's say I start with 1, not from 0. I start with 2 comma 10. So it will give me what? It will start from 2, 3, 4, 5, 6, and it will go till 10, and it will print. So let's see here, it starts from 2. Okay, one thing that you need to understand, I'll also put this in a comment here. Any range function, okay, it starts from starting point, starting number, starting numerical number, integer. It starts from starting integer. It will not accept your decimal, and goes till n minus 1. You just need to make sure, because if you see here, we have just said start from 0, start from 2, go till 10. It will go till what? 9. See here, it will go till 9. Okay, and if you want this to vary, so you see another object, if you have the detail, uh, it is not giving you, but yeah, it also accepts argument. And the third argument is like, how do you want to vary? Do you want to vary by 1? By default it is 1, 2, 3, 4 with the spacing of 1 number. If you want to vary it by 2, okay, so you just give 2. That means it will vary 2, 4, 6, 8, like this. See here, 2, 4, 6, 8. Okay, if you give, let's say, 100 and vary by 10, so it will vary. It will start from 2, 12, 22. It will vary by 10, go to 92. I guess we should be clear on this. Okay, so a range is important because all the loops that we'll see will somehow will start from this range function. Okay, all the condition that we'll build will start from range function. Okay, fine. Now let's move ahead and understand some statements, basically operators and data type. That is what is more that is what our most important thing. So in Python, we majorly have uh, uh, the data types that we talk about. Let's convert this into a markdown file. Okay, so just go here, click on markdown, highlight data type. So in data types we have numeric. Okay, one, that is one. Second will be your string. Okay, and what else you can think, guys? Any idea? What else you think can be a data type in for a programming language? Like if you have any other programming experience.
The float.
So third is float. Fine. Anything else? Anything else that you can think of?
Boolean.
So here in Python, it is very straightforward, and it majorly categorizes the entire programming is categorized into very few data types. Okay, and majority of them you'll see it's int, string. Okay, so that's it. You will not see anything like beyond very fewer time you'll get to see float, but this is it, nothing apart from this. So that's why it becomes very handy and to code here in initial days. Okay, and in if you come from any other programming background, so in that we used to declare this int x is equal to 10. So we used to explicitly mention the interpreter or the compiler that I'm declaring x and the type of x is integer. Okay, and the moment you give float in this, so let's say point 0, the interpreter will give you an error stating that the variable that you are declaring is of integer type, but the input that you are giving is of float type. Okay, this was the case, but in more of a advanced programming like Python, okay, here you just need to bother about x and give value 10. Now it's up to Python what it will interpret what x is, and it'll allocate the memory likewise. Okay, now if I talk about your x, okay, which I have declared as 10. So what actually happened is, in memory Python has created a space and stored 10. Okay, and it has clearly and intelligently identified what 10 is and stored the type as well. Now if I want to see the type of x, okay, I'll just type x. I'll just type a user function, system defined function type, declare the variable name and run it. So you get intelligently that it is integer. Okay, so Python understood that this is an integer. Okay, the moment you make it let's say the moment you make, let's say, y is equal to 10.0. Okay, so what you did is you added decimal to it. Okay, and if you check the type of y now, okay, so you'll get a float. Now it automatically understands that this is not a integer because it has a preceding a 0, that is it should be a float, and it declares a float. Okay, now another interesting thing, anything that comes anything Python sees which is in quotes, okay, it will assume that as a string. Very straightforward. See here, string, it automatically understands this is a string. Okay, now one more surprising, like that can come as a surprise to you is, like let's say I declare a variable a and I declare in quotes I declare 10, and I check the type of a. Can anybody tell me what will be the output?
String.
Okay, why so? Yeah. So the thing is very straightforward. That anything, as I said, anything that is in quotes, okay, even if it is a number, it will be assumed as a string. Okay. Now there's a way to convert the string into a number and then use it. That's a different thing. But yeah, this is it. This is how it is. Okay. So this is majorly, this is like primarily that we have in integer, float, and string. This is a prime data type that we have in Python. Okay. Now let's get into some operations. Okay, so the cell you can use for direct calculation if you want and to do some calculation. Let's say 100 divided by 10. Okay, so you can directly do it here itself. Okay, and the output is your integer. The output is float. It is doing some division. If you want to convert this into some other type, let's say I want to convert this into integer, I just need to write integer int bracket and the conversion, and see the type of the data, the output will automatically change from point. The point is removed. Okay, now if you see here, if I just type 8, so this will return me something with integer, something with decimal, right? Let's say I just print this first, there will be some output, then I print this. So what will happen, Python will convert the output. So it was 12.5 earlier. Okay, 8 divided 100 divided by 5, 8 will give you 12.5. Okay, once I convert it into integer, the decimal is removed and it is rounded off to nearest integer. Okay, fine. So this is this such operations you can do it in the cell itself. Now let's get into the operators that we have in Python. So the operators, almost all the operators that we use in any programming language is applicable here, and we'll quickly go through that. So arithmetic operators is basically all the mathematical operators that we do, plus, minus, division. Okay, so let's look into some of the operators. Okay, here. So we have addition. This all comes into arithmetic operators. We have addition, uh, division, we have floor division, we have modulus. So this is very important, modulus. Then we have exponential, that is like double star. Okay, we have subtraction, we have multiplication. Okay, so let's understand some of those. So plus with all is a simple addition, subtraction is a simple subtraction. We have division as well. Okay, so it gives you float. Division will always give you float type. If you check the type of this, it will give you float. Okay, now this is a float division. It gives you how many times it is getting multiplied with. Okay, and then comes the remainder, modular. So modular is it will give you the remainder. So if it 2 3 is 6, what is the remaining? 1. So you'll get 1 as an output. Okay, so this last one is your power 7 into 2. Okay, it gives you 14, and this gives you 7 to the power 7. This gives basically a square. 7 7 is 49. Okay, then comes your assignment operator. Assignment operator, one thing you need to clearly understand is, like, generally people get confused here, get like there are a lot of confusions here. So in Python and also in R, we have two operators. We have equal to and double equal to. So this equal to which you see here is called assignment operator, and the other is called comparator operator. Okay, now what is the difference? So if you talk about assignment operator, so what, like, let's say if you did x is equal to 10. So what I'm doing is I'm assigning the value of 10, numerical value of 10, to x. And what x is doing, x is basically allocate. It's not doing nothing, but it's creating a memory space for 10 and assigning it a name x. So it allocates some memory somewhere in the system, and it assigns 10 to that. Okay, and just rename that memory location as X. Okay, so that if you run it again, it will give you the value of, it will retrieve the value of 10 and it will give you as an output. Okay, this is one thing. The other thing is, 1 minute guys. Yeah, okay, so let's get back. Now if I talk about, so guys, this these are something very basic, but what happens generally when you start writing big codes, this confusions, you get error, and you are not able to, you will not be able to like fix that issues, because these basics will not be, if these basics are not clear. Okay, so now if I talk about x is equal to 11. Okay, so what I'm doing is, basically I'm comparing x, the value of x, that is 10, is it, if it is equal to 11 or not. Okay, so if, since there's only two options, if it is equal, it's fine. If it is not equal, so it is that, it means it is not equal. So the answer that you will get is, if equal or not equal, that is true or false, 1 or 0. Okay, so just run this, so you get false, because x is 10 and I'm comparing it with 11, I'm getting false. So the answer always remains boolean, true or false. If I give 10, so x is 10 and I'm comparing it if it is equal to 10 or not. So the answer says, yeah, it is equal to 10, and it will give you true and false. Okay, now if you can even convert this output into integer, that is your true and false, just convert this, so you get 1. If it is both the values are equal, and your output is true, true means 1, so that true will get converted from boolean to integer, and you get 1 as output. So if you do just 11, that means, the output is false, and false means 0, right? So it will give you 0 as output, right? And this is what the entire looping logic is based on, this comparator operator. That is how it is, so that is why it is so crucial. The entire looping and control flow conditional based thing is based on this double equal to. You never use a single equal to in control flow or loop condition. I hope it is making some sense here. Okay, so some other operators that we have in assignment is uh, this. Okay, uh, what does this mean is, basically, so x plus 7 equal to 7. Okay, if you see this with example, so it will be more clear. So if, when we use loop, so we'll keep this for looping condition, that time it will be more clear. Basically in an incremental operator. Okay, now these were just two operators in assignment. One is your equal to and double equal to, which is called assignment operator, and comparator operator. But comparator operator has many different forms. Okay, so some of them, will be greater than, okay, less than, greater than equal to, less than equal to, okay, not equal to, okay, not operator. This is called not operator. Okay, and then if in not also we have the not equal to, okay, or like that. Okay, so I'll just when I share this sheet with you, just have a look. You'll be able to understand one thing, that here like if you try and compare with some other programming language, so you'll get a understanding that logical operators have what we have in logical operators. We have apart from all this thing, greater than, equal to, less than, equal to, we have something called and operator, right? And we have something called or operator. Okay, so this is there as it is, but in Python you can write it in a different way as well, and can be written with ampersand. So don't get confused when you see ampersand, it actually means and. Okay, and or can be simply written as pipe. So both can be used. Now you can use not as a not. You can just write not. Okay, that means complementary operator, and you can even replace that with exclamation. So these three operators have multiple ways of writing it. Okay, you can write and with ampersand, or with pipe, not with exclamation. Okay, so that is more of operators, comparison operators. And you talk about any comparison operator, you talk about this, you talk about this, the entire comparison operator will give you, this is not a comparison operator, let's remove this, this is a separate thing, this is assignment operator. Okay, so entire comparison operator output will be a boolean. So everything will give you the output operator is boolean. Guys, any questions? Are we all clear? So if you want to see a couple of examples, I can just take you through. So let's say 7 greater than 10. Okay, I'm using comparator operator of comparator operator greater than. If I just run it, I'll get false. This is not this is not true, right? If I even use greater than, equal to, this is false. So everything will give you boolean output, true, false. Okay, 1 0 if you want to convert that. Okay, so let's move ahead and see what a logical operator we have already seen. Okay, bitwise is not important. We'll see a couple of examples. Now let's get into the core of Python. So we have variables in Python, variables and data types in Python. So data types we have already seen. We have string, boolean, we have integer. Okay, let's understand some of the like data structures. Okay, so what are the data structures in Python? Majorly, there are many, but what we are more bothered about is list. We not need to know tuple, dictionary, okay, and sets. So these are the important data types in Python, data structures basically. Okay, so we'll start with a list. Okay, so list is like it forms the basics. So let's start with list. So how do we declare list in Python is you declare any, like it is similar to declaring any variable. So let's say my list is li. I want to declare list. So it will be in a square bracket. Okay. So if it is in a square bracket, it's a list, and list can be of any type. Okay. So let's say I'm declaring list with number 1, 2, 3, 4, 5, 6. This is my list. Now, if I declare this list, so let's see. This is my list. If I want to check what the type of it this is, so it will give me. So since it's a list, it gives me a list as a output, right? Now you can even check the elements before coming to the element. We'll come to the element one minute. So before coming to the element, so it is a list, and now any data structures is basically we we need to index it. We need to retrieve the value out of it. So in Python, generally all the data structures uh, indexing starts from 0. Okay, it starts from 0. And if you guys have any background in R or something. So there we have indexing which starts from 1, right? So if say let's say I start I just need to pull the first element of my list, that is 1. So how will I do that? I'll just press li 1. What does that? It will give me output of 1. Sorry, li1 means it's since it starts from 0, so this is my first element, right? Now if I want to pull the first element, so what should be my index? It should be 0. If I just run it, so I get 1. So to pull the element, you need to start from 0 and it will go till n minus 1. Okay, and if I this is the positive index, positive indexing. And if you talk about negative indexing, so if I talk about li and if I press -1, so it starts from back. So -1 will give you this the last element. -2 will give you the second last, and likewise it will go till n. Okay, so let's see what -1 gives me. 6, the last element. Okay, now try this. Tell me what will be the output of this -2, -3.
Four.
Yeah, tell me.
4.
-3 will give me what?
4.
Okay, so let's check. It will actually give me the, if I run this, so -1 is this, -2, -3. So it should give me 4, right? That is exactly what the answer is. So that is one thing. And now if the list can get very complicated, okay, so let's say I create another list underscore 1, okay, wherein I'm giving element 1, 2, 3, 4, 5, 6. Okay, then in after 6 I give another element called a, b, c. So what does this mean? If you run this, so it runs successfully, that means that list is giving you list can have a nested, the list can become nested as well. So you have one list outside, okay, and then you have inner list. So this becomes your nested list. Okay, and once it becomes nested list, you need, if you want to fetch a, the first element of the inner list, how will you do that? Any idea or guess? Anyone who can guess it? If you can guess it, this. Okay, so see here. Now if I want what? I want this element. Okay, a. So where is a? What is the position of a? We start from 0, 1, 2, 3, 4, 5, 6. If you give 6, you get the inner list ABC. Now in this is one object. If you want the inner a, that means it is somewhere inside this. So if you, that is your 0th element of this second list, right? So you can give 0 here, so you get a as output. So you went to the list, inner list once, and then you want the first element of the inner list, so you just put 0 here. So just what you need to make sure is how brackets are being used to fetch the elements. Okay, now since we saw this example of nested list, and in nested list we had your integers. We also have had this characters. Okay, so it is a combination. So list can be a heterogeneous data structures. It can contain both string as well as numbers, right? It's a heterogeneous mixture. Now here it was just an integer list, so we got integer as an output, so it has only integers. Since here we have both integer and character, it is a heterogeneous. and this is the property. Now there are some inbuilt functions. If I want to check the element, what is the type of the element that list has, so how will I do that? I'll just check if this list one, li1, what is the type of it. So I can just put type. It will give me the type, the element, the each element. This is the inside, whatever you have inside, this is called element. So this one is first element, second element, third element. Okay, so this will give you what is the type of the element. So it says integer, right? And there are a lot of like this becomes your object. Li is your list is your object. So there are a lot of methods or functions inbuilt in R that you can use. So what is it basically is, so let's say li underscore 1. Okay, so if you press dot, so then you have all the methods uh, which you can use. So we'll come to methods and functions in couple of time, like in some time, but we need to understand this. uh, Here we are creating an object li underscore 1. Okay, now what this is basically a list. So anything that stores an element or a data structures or a data type, that becomes a object. So in object, if you use dot and press tab, okay, so whatever pop-ups you get, that are called methods. Okay, so that methods is basically which Python provides you to do some operation. So let's say if I write append, so append is basically adding an element. Okay, so here list is your, there are two types of object in Python. If you classify the entire object universe in Python, so there will be two types of object. One is something which is mutable, okay, and the other one is immutable. So what is the property of mutable? You can change it. Okay, what does immutable says? You cannot change it. This is a basic thing. Now since we started with data structures, so we'll classify our objects or data structures in this category. So list is something which is mutable. You can change it. You can add, remove, delete, whatever you want, you can do it. You can clear it. Okay, but when you talk about immutable objects, it means it is once you create it, you cannot change it. Okay, it means you cannot change it. Okay, now let's see some examples of list. Now if I do append is like adding something. I want to append some values. Okay, so how will I access it? So object dot methods, object dot methods is append. I'll just give a bracket, I'll write add 10. Okay, so what I'll see here is, and I go back to my list and I see li underscore 1. So I saw another element 10 got added right at the end. So earlier we had till here a b c and bracket closed, that's it. Now we saw another element that got added, that is 10, that got appended to my list. Okay, similarly, and where it got appended, so just understand the uh, like sequence where the position where it got added at the end. Okay, and it will not get added any random position. It will get added at the end element will be your new object. Okay, now if I want to remove something, so we need to see from where it is getting removed. Okay, for removing you have pop, okay, and remove, two methods. So let's see pop. Okay, I just want to pop 10. Okay, or if you want to remove, you can do that as well, try both. So sorry, the pop will take the position of it. So if you just write pop and enter, so it will remove 10. So it will remove 10. Why it is removing 10? It is removing the last element of the list. So if you need to classify this property of list, so it says the property is last, whichever comes in last in, last out. Okay, so let me remove this. So it is basically last in, whichever element comes in last in, first will be first to get out. This is the property, and this, in short, this is called defo. Okay, guys, are you clear in this? Now let's see some other methods to understand. Li1. Okay, if I want to clear something, so it will just clear my entire list, so you will get a blank list, there will be nothing. Okay, then you have count. It will give me how many elements I have in my why is this u coming? So if you want to see the length, how many elements you have in your list, so you just give length and it will give you the element size. So if you count here 1 2 3 4 5 6, this will become 1 7 and 8. So it gives you the length of since I have removed 10, 10 is no more existing, so that's why. So if we just print this like the updated list, so this is the element, and if you count, it has 7 elements. So this becomes one element. Guys, just be extra cautious on the very basics. This becomes your extra element. Any doubts so far? Any doubts or questions you have? Okay, shall we move ahead? So we saw methods. What your task will be to understand, because list is very important. So try and understand all the methods that you have. Okay, if you want to insert something, if you want to reverse the order of your list, so if you just reverse it, so it sorry, if you just reverse it, put in object, so what will happen? Now you have a list which is of what happened here. So for reverse, so this is not returning me the it is reversing my list, but it is not giving. I'll check why it is not returning you the output. But you individually check all the methods that we have, and if you call any object and using dot, so these are called methods. Okay, so and there's a difference between methods and functions. We'll see when we learn function, but if anything you call from the object is called methods. Okay, so your task will be to go through each methods and understand. So sorting is something you can see that it will sort your object. Okay, so let me remove this. I'll look into it why reverse and is giving you object, and I'll let you know. Okay, so further we saw that list can be a combination of both. It can be integer as well as string. So that is why it is called heterogeneous mixture, heterogeneous data type. Okay, now let's come to string. So string, it holds a similar property. Anything that encodes will be a string, and there's a way how you index. So string here, let me copy this part. So we saw mutable, we saw a list. Okay, whenever we talk about string as a data object, okay, it becomes, the example is your string. You cannot do any changes on a string. So for example, let's say we are working on this, let's create an example called string one. Okay, that it says this is my string. Okay, I'll print it, print as one. Okay, welcome to Python. Now if I need to access my elements of my list, so how will I do that? Indexing remains same, it will start from 0. Okay, it gives you the first element. 0 will give you the first element. Okay, and it will go till n minus 1. Now in a string, each space is counted as one character, which is whatever you see in between, that is one character. Okay, so if you need to pull out t, what will be the index? Any idea? So it will start from 0, 1, 2, 3, 4, 5, 6, 7, 8. So if you give 8, so you'll get t as an output. So that is how you can conclude that space is calculated or assumed as one character. Okay, now if I need to make any change in this, let's say s1 dot. Okay, so there are like methods. Capitalize, it will capitalize the entire, it will capitalize the, well, it's not working, I guess. Let me check s1. Give me a minute, let me just check once. Insert, pushing some element in some particular position, so this 2 becomes your position. Okay, and the element, so it does the exact same thing which append is doing, but append is by default pushing element at the back. Insert is pushing element in some particular location, whichever location you mentioned. Similarly, pop is removing element from the back. Okay, by default you don't need to mention any position, it will just simply remove the last element. But if you want to remove some element from any particular position specific, you just need to mention the position name, and it will remove the element from that position. This is the way. So I guess we have almost covered all the methods of a list. Reverse will basically reverse the item. So now you have 1, 10, 3. Okay, and then if you print li underscore 1, so once you reverse it, so it will get upside down. So 6 will become your first element, 5 will become your second element. Okay, see here, it is just reversing the integer. Fine, so I guess we have covered all the methods of string and list, so pretty much. So if something which is not covered, just explore it at your end, and if you have any doubts, let's discuss that in tomorrow's session. Okay, so indexing in string remains as it is. It starts from 0 and goes till n minus 1. Okay, and you cannot change element of a list of a string because it is immutable, right? Okay, uh, one quick question. This is my string, machine learning. Okay, if I want to pull the last element, okay, what will be my command? Let's say I want to pull the last element. This is my p. I want to pull my last element. What will be my command? Will -1 work, or it will not work? Just if you are using a system, just quickly run it at your end and check it. Let's move ahead. In this, if you have any questions, please let me know. And in just for just to understand, uh, length is a system function. Okay, it is giving me like the length of the entire characters, right? If I want to print each character, we let's just understand the procedure how we do that. We'll see the loop in detail now in some time. So we write for I in, so length. How do we use length? So we saw a range, right? How do we use range? But now we'll see how we use length. These two are important way of pulling out your character. So if I want to print each character one by one, so how will I do this? So I have uh, I have my string, a character which is stored in P, right? And if I want to store pull each element, so I'll just loop it on I. So I is your like it start from 0 till 16, 0 1 2 3 4, okay. And P1 will give me M, P2 will give me, P0 will give me M, P1 will give me A. I just print all the characters. So see here, I just need to change it, sorry. So so what will happen, it will print all the characters one by one. It will print M first, P0, then P1, P2, and likewise. Okay, so let's remove this for now. Let's move ahead. Okay, so in list we saw a lot of methods, right? So what are the methods? Methods are basically that we let's say this is my list 1 2 3 10 100 99 90. If this is my list, okay, so anything that we saw which comes as a dot, right? Li dot. So this is my methods, right? So we saw the use of methods. Now let's quickly see what are the different functions that we can use on this. So system functions will be like what we saw here, a length. Okay, same thing we can check here, length of Li. So it will give me the total elements that we have in the list. So that will count the number of elements, and it will give me the length of uh, Li. So what is the length of Li? 3. It starts from 0 0 1 2 3 4 5 1. So it gives you the count of total elements. So it's not indexing, sorry. So it's count of total elements. So it gives me 7. So there are other functions. So some of them are printed here. So if you want to see the maximum element, if the numerical uh, elements. So if you want to see the max, so you can use max function. If you want to see the minimum, you see the minimum function. Okay, so these are the different functions. If you can even like list, you can even iterate it. So if you want to print each element of a list, so let's say for I in range length of Li, right? If you want to print each element, how will I do that? Print Li, I want first element, all the elements starting from 0. So you can print it like this. Okay, it will print the first element, second element, third element, and likewise. Okay, so you can even iterate it. Okay, so let's move ahead. Adding elements and all we have seen, append, remove, all the methods we have seen, pop we have seen. Okay, if you want, guys, if you want to convert string to a list, how do we do that? We saw that right now using split, right? Fine. Now let's get into the third data structures, that is called tuples. So tuples, guys, it is exactly same as your list. All the properties and everything remains as it is. Only changes or only difference that you will feel is it is not editable. It is not mutable. You cannot make any changes in tuple. You can make changes in your list, okay, but you cannot do anything in your tuple. So let's see a couple of examples. I'll just create one tuple, 1t1. Indexing remains as it is. -1 will give you the last element. 1 will give it, and if you want to pull something from the front, it is 0 that you need to start with. Indexing 0 is give first element. Okay, and since it's a tuple, just write t1 and see there's no methods called append, remove. Okay, you have only two elements, count and index. That's it. Okay, so this is very self explanatory, that you don't have any you cannot do any activities which will change the data structure. So count will simply give you the count. Let's say count of the what happened? It again, tuple is something. I'll use length rather than count. So it gives me the length of, like, the number of elements it has. Okay. So this is the difference between tuple and thing. If you want to do any changes, so it will give you error. Let's understand. Let's say I want to change one. Okay, one is my, and how do you declare tuple? Tuple is it is declared in the same way, but with a normal bracket. Okay, and if I want to change anything, so let's say I want to change the 0th element. Okay, and I want to make it let's say to, I want to make it to 200 or 99, let's say. So it will give you an error. Tuple object does not support item assignment. You cannot do any changes. Okay, so in that list that we prepared above, tuple, you can add tuple in the you can add tuple in this immutable thing. Okay, we had string, then we had tuple now in this list. Okay, okay. So I guess 1 minute, I went. Yeah. So where are we? Okay, fine. So we saw tuple, and you talk about tuple, you talk about list. You can perform any mathematical operation in that. Okay, and we'll keep it till here today, and in tomorrow's session